Hello guys, welcome to another video, Stochastic Gradient Descent. So in the last video, we completed successfully gradient descent and we end up with some problems where gradient stucks in the local minima. So how to come from local minimum to the global minimum. So we will see the another technique for that problem. So this is the technique called stochastic gradient descent. Stochastic means random. So I will explain it shortly about this algorithm very clearly. First, we see some things before going into the stochastic gradient descent. You can think this is as a revise of gradient descent or something you can think. So what is our goal? We need to find the perfect gradients. That means that gradients at not local minimum, sorry, global minimum. So where we start from top of the bowl and we are taking some steps to the downside and finally we are end up with the global minimum. So this is called learning rate. Based on the learning rate, we will take steps, either big steps or small steps. When the learning rate is too slow, so our model will that gradients will take very small step from top to bottom. So this affects the time. So it will take a lot of time to converge those gradients to the not local minimum, or global minimum. And another thing is when our learning rate is too large, so our gradients will jump from this side to this side and this side to this side, like that. And another thing is we can, in the last video I didn't change the learning rate, so I kept the 0.01. Now you can go and change that learning rate and you can play with that learning rate also. So you will find these things. If learning rate is too high, you will get some nan output. That means not an integer. Sometimes when our learning rate is very less, then our model takes a lot of time to converge. You can visualize that thing also. So the problem with gradient descent is sometimes it stuck at the local minimum. So can't get from the local minimum to the global minimum. So what is the solution? Stochastic gradient descent. So here I want to refer one time. Batch gradient descent is same, nothing but gradient descent only. Batch gradient descent means taking the old data and passing it to the model, and finally we are getting the weights and global minimum values, gradients. That means batch gradient descent means whole data. But in the case of stochastic gradient means we are going to take only one instance and we will pass that instance to our model and we will find the gradient and we will take. So here is the definition. Stochastic gradient just picks a random instant in the training set at each iteration and compute the gradients based on only single instance. So due to this, we can overcome that problem. So when we stuck at the local minimum, by using this technique, so our gradients will bounce from local minimum to the global minimum. And there are some problems with this technique also. So I want to say these techniques. So what is the main problem is the gradients will bounce in this technique. That means when they are coming to the global minimum, they won't stop. They will bounce again to left side to right side or right side to left side somewhere. So you will get very good gradient values when our algorithm stops, but those gradients are not optimal. That you have to remember. So how to solve that problem? One solution is there. You have to reduce the learning rate after each iteration. That is called simulated annealing, or you can call it as learning rate decay, or anything you want. That is the solution for this problem, for this pitfall or downfall. You can reduce the bounce rate. So finally you will get very good optimal values by using this learning rate schedule. So this is the overall idea of the stochastic gradient descent. And another thing is I want to say that these pics are taken from Aurel Libu. So you can refer his book also, Machine Learning. So actually I follows that book only when I was a beginner. So that book is really very helpful for beginners. So you can read that book, Hands-on Machine Learning with sklearn and TensorFlow. Okay guys, we seen about stochastic gradient descent. So in the next video we will see how to implement this stochastic gradient descent from scratch and how to use sklearn library. The actual sklearn library provides this stochastic gradient algorithm by built-in, so you can use that library also. So how to do that I will teach you in the next video, I will say. Okay guys, thank you. I will see you in the next video.